Yo guys, welcome back to this channel. Nice to see everyone again. And for today's video, we'll cover the physical properties of carboxylic acid. I split the physical property into two parts. Today will be the part 1 of it. And in this part 1 video, we'll discuss only one thing, which is boiling point of carboxylic acid. Let's jump straight into the boiling point of carboxylic acid. We have two conditions that we are going to look at today. The first condition is we are going to compare within carboxylic acid. Means I'm going to compare two carboxylic acid and see which one have higher boiling point. Another one, you can compare your carboxylic acid with alcohol. Means you can compare your propanoic acid with butanoic and we'll see which one have higher boiling point. And we will start off with comparing with your carboxylic acid. And we have factor affecting the boiling point when we compare within our carboxylic acid. So the first factor will be the number of COOH group. If I'm talking about my boiling point need to be go higher, the number of OH group also need to be higher. The higher the number of OH group, the stronger the hydrogen bond, the more hydrogen bond you have, therefore boiling point will increase. The second factor that will affect the boiling point will be, as always, the molecular mass or the number of carbon atom. When the number of carbon increase, the molecular mass will also increase, resulting a higher boiling point. Last but not least, the third factor that will be affecting the boiling point of carboxylic acid will be the molecular shape and also contact surface area. If we are talking about higher boiling point, if I want my boiling point to be higher, my molecular shape needs to have a larger contact surface area. Bear that in mind, the one that have the largest contact surface area will definitely be your cyclic, followed by your straight chain, followed by your branches. I hope you remember all these three factors that you learn exactly the same in your alcohol. So let's jump straight into our first example. The first example that I have on the screen is my butanoic acid and also my butane dioic acid. Dioic acid over here means I have 2 COOH. Both having 4 carbon. My butanoic acid will look something like this. My butane dioic acid will be a COOH, CH2, CH2, and also another COOH. And you can see over here, in your butanoic acid, you only have 1 COOH. In your butane dioic acid, you have 2 COOH. And which one will have a higher boiling point? Obviously, this one will have a higher boiling point because your butanoic acid only having 1 COOH group, while this one having 2 COOH group. Therefore, which one can form more hydrogen bond? Your butane dioic acid will definitely form more hydrogen bond. Compared to your butanoic acid, we still have hydrogen bond, but we will form less hydrogen bond because the number of COOH group is lower. When less hydrogen bond over here means less energy needed. When less energy needed, therefore the boiling point over here will be lower. Compared to your butane dioic acid, the boiling point will be higher because you form more hydrogen bond. Therefore, automatically you need more energy to overcome the strong hydrogen bond. And that is quite obvious over here. Let's look at the sample answer that I can give to you. I name my butanoic acid as my compound Q. And I name my butane dioic acid as my compound P. And the first point that you should mention will be the number of COOH group in your P is more than your Q. Your P having 2 COOH, while your Q having only 1 COOH. Next, you mention your compound P therefore can form more hydrogen bond with itself than the compound Q. Bear that in mind, hydrogen bond is a type of attractive forces. We cannot count how many hydrogen bond, but we can use the word less or more. Bear that in mind. When you can form more hydrogen bond in the P within itself, therefore, more energy will be needed to overcome the strong hydrogen bond in the compound P rather than the compound Q, because you have more hydrogen bond which is so strong. As a result, your compound P will have a higher boiling point than your compound Q. Easy? Simple. The same sentence that we always use, but right now we are changing it to carboxylic acid. Let's jump into another example. Another example that we have right now is our butanoic acid and also propanoic acid. So your butanoic acid over here is a 5-carbon carboxylic acid because it's a penta. So my butanoic acid shall look something like this. 3 carbon, 4 carbon, and my 5-carbon carboxylic acid. My propanoic acid, on the other hand, is a 3-carbon carboxylic acid. So it shall look something like this. And what makes them similar? Both having one COOH group. When both having similar COOH group, which means both will have a similar hydrogen bond. And when both having similar hydrogen bond, can we still discuss hydrogen bond? No, you cannot discuss hydrogen bond because they are similar. And in this question, what makes it different? The number of alkyl group that you have behind here. The alkyl group over here, your R group, obviously is bigger. When your R group over here is bigger, in the other words, number of carbon increase. Therefore, the molecular mass over here for your butanoic acid is higher than the molecular mass that you have over here. The molecular mass over here is lower by 2 carbon, right? And since we are not going to talk about hydrogen bond, both of them therefore will discuss about van der Waals forces. And we know that van der Waals forces is highly affected by molecular mass. When the molecular mass over here increases, van der Waals forces automatically increases. Vice versa, van der Waals over here will be weaker because my molecular mass is lower. And since the van der Waals forces right now is higher, therefore this guy will need more energy. When more energy, automatically your butanoic acid will have a higher boiling point than your propanoic acid. The propanoic acid will only need a less amount of energy. Because the molar mass is lower, therefore van der Waals forces is weaker. See that? Bear that in mind, we are not going to discuss about carboxyl group. We are not going to discuss about hydrogen bond because they are similar. We only discuss the different factor. And the second factor, when the number of OH group is the same, is the molecular mass. Okay? Let's look at the sample of answer. My butanoic acid right now is named as compound R. My propanoic acid right now is named as compound S. So the first point will be, the compound R has a higher molecular mass than my compound S, obviously because the number of carbon is higher. The second point over here, your compound R therefore can form a stronger van der Waals forces than the compound S. Bear that in mind, the higher the molecular mass, the stronger the van der Waals forces. Therefore, you will need more energy to overcome the strong van der Waals forces in the compound R, which has a higher molecular mass. Last but not least, the compound R over here will have a higher boiling point. Simple. It's the same thing as what you have learned previously, but right now is about carboxylic acid. And we can discuss the factor of molecular mass because they have the same carboxylic acid group. Both are having one COOH. So we cannot discuss about the first factor. We move on to the second factor. Okay? Another example for your carboxylic acid. I have my hexanoic acid and 2,3-dimethylbutanoic acid. My hexanoic acid is a 6-carbon carboxylic acid. So the straight chain 6-carbon should be something like this. 6-carbon carboxylic acid, 1, 2, 3, 4, 5, 6 hexanoic acid. Next, I have my 2,3-dimethylbutanoic acid. Butanoic acid is a 4-carbon straight chain. Holding the carboxylic acid, this guy will definitely carbon number 1, carbon number 2, carbon number 3, carbon number 4. Carbon number 2 holding a methyl group, carbon number 3 holding a methyl group. Complete the structure, you have your CH3, you have one more H to complete the 4 bond of carbon. And that is my 2,3-dimethyl butanoic acid. And over here, what you realize is the total number of carbon is the same. I have 6 carbon in total. I have 6 carbon in total. Okay? I have 1 COOH group. I have 1 COOH group. So, number of OH group is the same. The number of carbon is also the same. 2 factor is the same already. Then only we can move to the third factor, which is your contact surface area. So over here, contact surface area, who is larger? Your hexanoic acid over here is a straight chain with no branches. And compared to your 2,3-dimethyl butanoic acid, is a straight chain 4-carbon with 2 branches. So having a straight chain and having a branches, which one is more compact and which one is having more contact surface area? Your straight chain structure will be less compact molecule, and therefore you will have a higher contact surface area. Vice versa, when you have branches, it will be more compact. Your structure will be more compact and smaller. Therefore, lower contact surface area. Okay? And when the contact surface area is different right now, which one will give you stronger van der Waals forces? Of course, the larger the contact surface area, more area will be exposed to the van der Waals forces. In the other words, your van der Waals forces will be stronger when you have larger contact surface area. And guys, stronger van der Waals forces, which one do you think have higher boiling point? Of course, the straight chain that having a stronger van der Waals forces will have a higher boiling point compared to the branches that have a lower contact surface area and lower or weaker van der Waals forces. Okay? So make sure you know when can we discuss the third factor over here is when your first factor is the same. Your second factor, the number of carbon, also is the same. Then only we move on to the third factor. Okay? Let's look at my complete explanation of this. My hexanoic acid right now is a compound T. My 2,3-dimethyl butanoic acid is a compound U in this case. The first sentence will be your compound T and your compound U having a similar molecular mass. You can add in and same number of COOH group. Okay, both are the same. The second sentence will be your compound T is a straight chain while your compound U is having 2 branches. Straight away going to the molecular shape. Okay, talking about the straight chain or the branches or even cyclic if you have a cyclic. Next, we will then move into contact surface area. When your T is a straight chain, your T will then have a larger contact surface area than the U. Okay? From the molecular shape, moving straight to the contact surface area. Next, the effect of the contact surface area, the larger the contact surface area, the stronger the van der Waals forces. So, relate the contact surface area with the van der Waals forces. The larger the contact surface area, the stronger the van der Waals forces. Therefore, more energy is needed to overcome the stronger van der Waals forces in your compound T, which is the straight chain carboxylic acid. Last but not least, as a result, your compound T will then have a higher boiling point. Simple, alright? It's actually the same thing as your alcohol, but right now we are comparing your carboxylic acid. Okay? They are very, very similar. Even the sentence of explanation are very similar. I don't want you to take this as a new thing. They are exactly the same as the boiling point that you learn in your alcohol. Alright? So next, we are still at our boiling point, but we are going to compare our carboxylic acid with alcohol right now. So we have two things. We have carboxylic acid, we have alcohol. Let's look at the way that they form hydrogen bond with themselves first. For the carboxylic acid, that is my COOH, and that is my hydrogen bond force of attraction. Okay? For the alcohol, that is my force of attraction of hydrogen bond between alcohol. So by looking at this hydrogen bond in the carboxylic acid and also the hydrogen bond in your alcohol, which one do you think form more hydrogen bond? Obviously, your carboxylic acid will form more hydrogen bond with itself compared to your alcohol. Your alcohol will form less hydrogen bond with itself. Okay? And other than more or less hydrogen bond over here, I hope you can see that your carboxylic acid right now forming a dimer. Alright, your carboxylic acid over here forming a dimer. Okay? So that is the dimer that will cause the hydrogen bond that you form is extremely strong. Okay? Other than more hydrogen bond, it will be also stronger hydrogen bond. And this stronger hydrogen bond is formed through one word that we call dimerization. Okay? So bear that in mind. Carboxylic acid is not only able to form more hydrogen bond, it will also be able to form stronger hydrogen bond through dimerization. And looking at this, carboxylic acid and alcohol, which one do you think have higher boiling point? Obviously, your boiling point of carboxylic acid were higher compared to the boiling point of your alcohol, with one condition that have similar molecular mass. So we can only compare the carboxylic acid and the alcohol with a similar molecular mass. Alright? And when the molecular mass between carboxylic acid and alcohol are similar, obviously carboxylic acid will have a higher boiling point. Because carboxylic acid can form more and stronger hydrogen bond through dimerization. So remember that. Next, let's look at some example over here. I have my presence of ethanoic acid and also propanol. My ethanoic acid is a 2-carbon carboxylic acid, while my propanol is a 3-carbon alcohol. So obviously, we'll talk about that. Which one have higher boiling point? Definitely your ethanoic acid. And your propanol definitely have a lower boiling point. And the only sentence that we need is because your carboxylic acid can form more and stronger hydrogen bond through dimerization. And that is the only reason why your carboxylic acid is having a higher boiling point than the similar mass alcohol. Alright? Simple. Let's look at the complete sentence. I have my ethanoic acid over here. I have my propanol over here. And the first sentence that we can have is, both can form hydrogen bond. Yes, because both having the ability to form hydrogen bond with itself. However, the ethanoic acid can form more and stronger hydrogen bond through dimerization because it's a carboxylic acid. As a result, more energy needed to overcome the stronger hydrogen bond in the ethanoic acid. Thus, the boiling point of ethanoic acid is higher than the propanol. Easy? Very simple. Whenever you have carboxylic acid and your alcohol, and as long as they are having in a similar molecular mass, the only things that we want is this sentence. Okay, carboxylic acid can form more and stronger hydrogen bond through dimerization. And this is the only new thing in the boiling point of carboxylic acid. The rest are similar as previous. And we have come to the end of this part 1 video of physical property in carboxylic acid. I hope you like this video. Therefore, make sure you hit the like button and subscribe to my channel for more informative chemistry video. Thank you for watching, and I'll see you again in the next video for part 2 about solubility.